Get right into our next speaker here, Rich Merhige, who in 1992, and incidentally one of our main sponsors, Rich founded Advanced Maintenance Engineering and later in 2002 Advanced Mechanical Enterprises. He attended the State University of New York, Maritime College, bachelor's degree in marine engineering, continuing education in systems and ocean engineering at Virginia Polytech, George Washington University, further specialized training earning a Coast Guard license, second assistant engineer, steam and motor, unlimited horsepower, et cetera, et cetera, et cetera. He's got quite the resume, but of all the organizations he's associated with, you know you've arrived when you are a member of the Vibration Institute, which I guess has got some kind of distinction to it. Now, I don't know the title, Keeping Your Driveline in Line with Condition Monitoring. I have clueless. It sounds more like a new workout regimen, fad of some sort, fitness regimen, but knowing you, that's probably not true. And ladies and gentlemen, Rich Merhige.
Good morning, everybody. Just driving in today to do this presentation down A1A, and I'm like, wow, we live in a fantastic spot. I mean, this is great. I mean, the ocean was stirred up. There was 2 tankers offshore. I didn't see any yachts out there this morning. A little choppy. Anyway, welcome, and I guess I'm talking about yacht security. Do you need my memory stick? All right, I don't feel any vibrations, so. I'm here too soon. All right, I don't have any good one-liners. There's a bunch of guys talking about vibration. All right, there we go. This is how I advance it, I assume. And the green button's for advance, and then there's a laser. Cool. All right. So I'm here to talk about keeping your driveline in line with condition monitoring. All right, this is just a collage of things that I just, things I've done over the years that were kind of cool. And working in this industry has been like, I mean, you never know what you're going to do one day to the next. It's awesome. So when I was a young engineer, I had a great opportunity to sea trial the battleships when they came out of mothballs. I was there when they fired the guns. That thing was unbelievable. I mean, that 16-inch guns. And, I mean, that's nothing to do with condition monitoring, but and then there's me posing, taking a vibration readings on a yacht. That's the training ship that we did over the summer. I went back as a watch officer on 2 cruises. I love teaching people. It's really fun to teach people. I've actually taught some of my competition. So then we have, there's a container ship that I worked on. I sailed for 4 years in the Merchant Marine, and then there's us, there's our team. We're discussing a pose photo and how we analyze data. All right, so keeping your driveline in line. So the idea here is, with the yachts, the owner, our whole goal is for the owners to have a pleasurable experience, not have breakdowns, maybe spend a little money to avoid breakdowns and keep up with their maintenance. And the whole concept with condition monitoring is doing additional tests and measurements to avoid breakdowns. And some of the things that you can do here is vibration analysis. Vibration is a very powerful tool. It's like going to the doctor and getting an EKG for your heart, where you're, they can see if you've got a bad valve or something else and your pump's not working right. Same thing with the vibration analysis. We can pick up misalignment. We can pick up misfire in an engine. We can pick up bad mount, something out of balance, all that stuff. Oil analysis for the reduction gears, taking a sample from your reduction gear and your lube oil for your engine, and doing this, I'd say every quarter would be great, because you can see the wear patterns and make sure you're not doing any damage and everything's running well, not getting any water intrusion, things like that. This is a diesel. We have a diesel engine analysis system. It's really more for the larger engines, and this is a very accurate tool where it times vibration, ultrasonics, and firing pressure to each cylinder, and we can, and for diagnostics of an engine, it takes it a level beyond what the onboard computers are able to do. And then these two things here are not really condition monitoring. This is corrective maintenance, and this is where this is a laser alignment system that we use for aligning engines to gears, and this is a bore scope system we use for aligning shaft lines. So vibration analysis, benefits, reduces, by knowing what's going to happen or trending a vibration problem, you can plan in advance. We just flew out to Staniel Key to do an analysis on a yacht that had a coupling failure. They were worried about the other engine failing, and we were able to tell them, hey, you're going to be okay, you'll make it back. We can plan in this maintenance, and we can buy the parts in advance, we can get everything lined up, and you can save some money by not having a complete panic. So that's vibration analysis is good for that kind of thing, and picking up problems before they come major. And also for trending those problems and making sure that they're not getting out of hand. So these are some of the things that, the benefits. Reduce equipment costs, reduce labor costs. These are all things that benefits of knowing in advance, having knowledge before you have a breakdown. All right. This is like, this here was, so the instrument I showed on the last slide, this is a portable instrument. We use this, some of the shipyards have us do a vibration survey before the vessel goes into dry dock, and we get a baseline signature of the boat. We can identify if there's some things that aren't on the maintenance list that should be, and then we do a vibration analysis afterwards. So this is a portable system. It's handheld. And you can see there's the sensor. You walk from point to point. We pre-program a database in advance, and you take data and you dump it back in the computer and analyze it. And we do a before and after in the shipyard, and it protects everybody. It protects the shipyard, it protects the owner, it makes sure the job's being done properly, make sure things weren't missed, because you have a signature before and after. Now this system here, this is we represent this company, Proof Technic. But this is a sport fish that has this monitoring system, and we're getting engine data, vibration data, and I can't quite see that, but we're monitoring both engines. There's a Seakeeper gyro system. We're monitoring the vibration from all these systems permanently, and this data can be then transmitted you could look at it on your iPhone, your laptop, and you could sit at home while the boat's cruising along in the Caribbean with the captain in charge, and you can actually monitor the boat and see what's going on all the time. So this shows the setup. So this is a permanently installed system. It gives a greater level of protection, and it's monitoring vibration off the engine, it's monitoring RPM, it's monitoring vibration off the Seakeeper, and it also is taking in all the engine data as well. And all this is available for you to see remotely, provided you have satellite communication or a cell phone communication. When they hit port, you can get a data dump, and you'll be able to get a historical data of what's been going on with your boat constantly, which is kind of nice. All right, so this shows this is a U-joint shaft, and it shows you know, the picture's turned vertically. It really should be the other way, but it shows the, this is the laser alignment system set up across the U-joint shafts. Again, you know, proper maintenance, proper setup, making sure the alignment's good from the outset when the boat's delivered to your customers makes that boat run well, have a long life, no hassles for the owner. I mean, you want to control as much as you can. There's some things at sea that you can't control. Things happen. But you want to control what you can control, and having a good alignment and having the thing set up right for when the guy accepts the boat is really important. You don't have a frustrated and upset customer. You got a guy that's out there enjoying the Bahamas or the Caribbean and just having a great time. This is one of our guys in the process of doing, again, you know, proper alignment. I'd have to say that majority of things we see wrong are alignment problems. I mean, once the alignment's set up properly, you save fuel, you put less wear and tear on the engine, all that stuff. It's less wear and tear on the bearings. It's a win-win, and it's not that expensive. So that's an optical bore scope. It's been around since the 1900s. I'm sure they used them on the Panama Canal when they built it. And that is old technology. We also have lasers for doing this kind of work. We tend to use them on the larger yachts with shafts greater than 6 inches, you know, where we need that kind of precision and accuracy for like an oil lubricated stern tube. This is a water lubricated stern tube. And optical alignment is a very practical and useful technology. It's been around for hundreds of years, you know, hundreds of years. All right, diesel engine condition monitoring. Again, this tends to be we work on the larger engines with this, but you know, if we're able to, this is one of the few technologies where you can actually get condition of the engine as it's running. Increases reliability. You can learn which machines, you know, what needs to be, if you've got a misfire, you can pick out which cylinder it's at. I mean, sometimes the cylinder cutout test doesn't always pick it up. So we're able to pick it up with this technology. Oil analysis. I think oil analysis has become more and more accepted. I think most people are doing oil analysis. Laboratories are out there, and people are using it, and it makes sense. And it's a low-cost way of doing condition monitoring of your hydraulics, any fluids on the vessel, coolant, hydraulics, oil should all be sent into the lab. And I mean, I suggest quarterly. It depends on how much you run the boat. If you're not putting a lot of hours on it, you know, twice a year would probably be fine. But condition monitoring is a very, very valuable tool, and oil analysis is one of the founding, you know, along with vibration, is a really strong foundation for that. Okay, so again, condition monitoring helps you pre-plan and save money. And that goes back to my friends in Staniel Key that, you know, wanted to know if they were going to be able to make it safely back and not have to fly a team over to the Bahamas to do the job. And we were able to advise them that they could. So that's just an example, but you can pre-order parts. You can lay out the project and plan in advance, and you can review history and records and see, you know, what needs to be done, what parts and components need to be changed. So this is just showing some examples. This is a water lubricated stern tube that didn't get water. Where you could identify something like this is so by having additional sensors installed on the boat, such as a flow sensor that would alarm, or a temperature sensor which would alarm, could help avoid situations like that, which was basically due to an inexperienced crew not having a proper, they had actually too many valves open and diverted water that should have been going to the stern tube going overboard. So they didn't realize, and I don't think it was an easy mistake to make, and unfortunately that was the outcome. And again, this is the bore scope, and I don't know what, there's a propeller there. So we're talking about hull blocking, okay. So when you do an alignment, proper, this is, you want to, again, condition monitoring goes, what we're finding is a lot of alignment problems, and some of those problems have to do with hull deflection. When the boat is hauled, it's very important to block the boat properly so it's not hogging, and do a proper alignment, because you can actually induce a misalignment if you're not careful, if the boat wasn't blocked properly. Okay, you're talking about props and shafts, okay. Torque measurements. Propeller, again, this goes back to doing measurements and condition monitoring, making sure that your props are correctly sized for your engine. The load indicator on your engine is an algorithm that's based off fuel flow and RPM. We actually physically measure, and we're actually doing this on a job on a yacht in Los Angeles right now, in the LA, where the engineer is not sure if the boat's, he's getting an excessive load on his engine, and he's not sure if it's prop related or if the engine's not performing correctly. So what we do is we put strain gauges on the propeller shaft, and we directly measure the power output at the propeller shaft itself, shaft horsepower. So by knowing the physical power to the propeller, we're able to tell him, hey, your engine's running fine, you're over-propped. And that's really the only way you can truly do that. You can't really, it's difficult to do that off the engine data properly. So the real true way is measuring the torque at the prop shaft itself, horsepower. Torque times RPM, horsepower. So, we'll see how that turns out. But we'll see if he needs a, I think he's going to need to do something with the prop, but. Okay, optical alignment inspection. Again, I spoke about that earlier. Cutlass bearings, you can see what happens when you don't get water. Hydraulic inspection. One of the things you can do for a condition monitoring tool, and it's relatively inexpensive, is measuring ultrasound. So with ultrasound, you can hear hydraulic leaks. You can hear, if a valve is not properly closing, it'll create a sound above what the human ears can hear. And these ultrasound instruments are not that expensive, and they're very valuable for also picking up like failed bearings, things like that. Roller bearings, not cutlass bearings. So that would be something used in a gearbox. All right. That's not a sheared propeller blade, but it's nicked. Vibration analysis would pick that up in the form of what's called blade rate. So when we do a baseline vibration survey on a boat coming in, they have a vibration, they don't know what it's from. We could pick that up because the number of blades times the RPM produces a frequency called blade pass frequency. And blade pass frequency would be picked up by vibration analysis. Cutlass bearing wear. So what happens when a cutlass bearing wears, you'll start seeing vibration at shaft RPM. The shaft will potentially start to wobble, or you get what's called a whirling frequency, where the shaft is actually oscillating inside the bearing. It's called a whirling frequency, and that'll show up in vibration analysis. All right, so this is nothing from, this is electrolysis, which is a big issue. And one of the things I think that's difficult with yachts is they often sit for long periods of time, and you start getting what's called, crevice corrosion. And very, very important to maintain your cathodic protection. And also, I think if a boat, the worst thing is for a boat to just sit. I think somebody needs to get down to the boat and turn the shafts over at least once a week and get water flow through the stern tube. Otherwise, you're going to end up with cathodic problems like this, which are very expensive. Buying new shafts is not cheap. And, the haul-out cost and everything else. And what can happen here is when you get that kind of pitting in a stern tube, it'll cause cavitation of the fluid film that lubricates your bearings. So what'll happen is the cavitation will eat up your cutlass bearings, and this becomes like a slippery slope that just aggravates itself more and more. So just something to, cathodic protection, zincs, turning the shafts, having water flow through the stern tube, for a boat to sit months at a time, and I see that, all around town. Somebody really needs to get down to the boat and get a little, turn the shafts over, get a little water flow through the propellers and through the stern tube. You got to use the boat. All right, delaminated cutlass bearing. So you can see what's going on there. The bearing is separating. That could get ugly real quick. The bearing separates, and what happens is then it exacerbates, water penetrates in there, and then you can get corrosion between the bearing. You get corrosion between the bearing and the metal. The metal expands even further, presses the bearing against the shaft, and this gets pretty bad. That's typically a delaminated bearing, from my experience, is caused by a bearing that's overheating. Again, poor water flow when you're operating causes the bearing to overheat, absorb water. It starts to delaminate, and it separates, and this just goes from bad to worse. Rubber cutlass bearings are pretty durable. They can take a lot of abuse, and they can actually handle quite a bit of misalignment, from what I've seen, and they'll still continue to operate. And it's rare when you see a rubber cutlass bearing completely destroy itself, but they're very prone to, if they don't get water, that can be a serious, you can't ever not have enough water to a bearing. You got to keep these things lubricated, and if they overheat, and it's not usually the one in the strut. The strut bearing will overheat. I've seen where a line wraps around the prop, and then it obstructs water flow to the strut, and that's when you'll see something like this happen. But rubber bearings are pretty tough, I got to admit. Okay, so this is a job we did recently where, unfortunately, we took the oil filter out, and there was a ton of bearing material inside the lube oil filter. Not something you want to see. So things like lube oil analysis and vibration analysis of a reduction gear may have caught whatever caused this before it got to this point, because this is going to require a pretty significant rebuild of the gearbox. In my experience, the gearbox is the most precision piece of equipment in most drive lines. So if you have a misalignment of your reduction gear to your shaft line, it'll overload the bearings of the bull gear, and this is what is the end result. So this is typically caused by something causing a misalignment of reduction gear. That's more pitting. That's pretty deep. Can't be repaired. So the strength of a shaft, people think, why don't you just machine it down and weld it back up? Well, you could do that. In some cases, you could do that. But the strength of materials, the outer diameter is where the greatest strength is, and as you go toward the center, you lose you lose strength. So once you've had a pit or a damage to the outer diameter of the original material, the structure is no longer, you have to go to the deepest point of that pit, and that's your strength. So your strength is from your outer diameter. So once you've cut this down, you've lost strength. And you can't win it back by welding it. It's not going to get the strength back. So Lloyd's is pretty strict about this. Lloyd's will condemn the shaft, and you've got to get another shaft. ABS is more, they have a more practical approach on that, and ABS will let you repair to a certain depth, depending on how much percentage of the shaft is damaged. So they will let you repair that, but again, you lose strength when the shaft, and there is a safety factor, but this kind of thing is, and you know, most of that's caused by sitting and letting crevice corrosion just eat away at the metal. And it was always fascinating to me that stainless steel, which is a fantastic material, can be eaten away by crevice corrosion. It's unbelievable. Okay, this is showing engine mounts. That's a torsional coupling, and that's a shaft seal. So these components of your driveline, a lot of misalignment problems go back to the engine mounts. A lot of builders and installers don't understand that these mounts are actually as critical as they are. We had one vessel we just recently did some work on where the engine mounts have to take thrust from the propeller shaft and torque, and they had these little locking devices that went into the mount to prevent it from, it kept the mount clamped together. And what happened was the builder omitted that by inadvertently, because this mount looks like another mount. They're like, oh, it doesn't need these things. Tossed them out. What was happening is the propeller thrust was pushing the whole engine up in the air and tilting it down. It was pitching it. So, brand new boat, well-known builder, beautiful yacht, was bending the shaft, brand new boat, vibrating like crazy, and it was just because these little clamping devices that go in the mount were missing. Another vibration analyst went on there. He said they had structural problems and all this other stuff, and I'm like, no, you're just missing these little clamps. So we put the clamps in, did a vibration. It was the vibration on the engine was around 1 inch per second, which is a lot of vibration, and we got it down to less than 0.2. So it was just some little thing that was omitted. These are overlooked, torsional couplings. Excuse me. The rubber in these, rubber has about a 10-year life. If you don't maintain the vessel, so 10 years is a major life cycle in a yacht. And these rubber components, the mounts, the coupling, the rubber components need to be replaced. There's no way around it. They age out, and it's nothing to do with running hours. They just dry rot. They lose elasticity, and then one thing leads to another. So you've got to, this is overlooked all the time, and it causes a lot of vibration issues. These torsional couplings help to smooth out the firing of the engine. The acceleration and deceleration is caused by the piston firing, and these couplings are like a shock absorber for that, and when they lose their elasticity, it can shake the whole boat. So, and then again, these seals, that particular seal is a Wärtsilä seal. We happen to represent them, but they have a rubber bellows as well, and they're, again, maximum 10-year life, just the way it is. So when you have a brokerage vessel that's 10 years old, these are things you need to consider when you sell that boat. The rudders mentioned, of course, rudder bearings are another consideration. We do what's called a bump test to see how much play is in the rudder bearings. Strut inspections, you want to make sure no water's leaking out between the bond of the strut to the hull, and that's tight. That is often overlooked. If a vessel had a grounding, that's something you want to look at, is the strut integrity to the hull. This is another thing that's overlooked a lot. Sea cocks, sea valves. Very, very important to your propulsion and your vessel cooling water or air conditioning. Valves should be exercised regularly. So valves should be open and closed at least monthly, and if they're not, you'll pay the price, because what will happen is between marine growth and corrosion, that valve will never move again. So this is another item that's overlooked. Boat sits in the water, nobody exercises the valves. Valves need to be exercised monthly on a maintenance program. Ultrasonics and infrared, I mentioned ultrasonics earlier. Infrared is a very valuable condition monitoring tool. We use it on commercial ships to survey their electrical switchgear. So the switchboard will get hot spots in it, as well as all the panels and the motor windings, and you can see that with infrared technology. They have infrared cameras now that can snap on your phone. I mean, talk about low cost and easily available, and you could be checking your electrical switches and switchboard, especially on the AC side. The DC power doesn't really get that hot, but on your AC, you want to do your infrared inspections. The other thing you can use infrared for, which is interesting, in composite vessels, you can see water intrusion into the hull. So it'll show up as a temperature differential, and we've used that to identify damage to and delamination in fiberglass. This is an example of a tides bearing where this was a very bizarre case where they had, and it goes back to the original setup, they have the water flow. There's always got to be water flow going into your bearing and your stern tube. It's a lubrication, it's a flushing, and it's very, very critical toward the operation. And I mean, you could sink a boat if you're not careful with this stuff. So what happened here? This was interesting, where I guess what had happened was you have water feeding into both stern tubes. It usually comes off the cooling for the engine. It usually comes off the oil cooler for the reduction gear. So you have water going into your stern tubes, and they had a crossover line between the two that didn't have an isolation valve. So water could, water's going to take the path of least resistance. So if one side has a slight obstruction or anything like that, all the water is going to go to the other side. And I think that, in combination with this is a semi-displacement yacht. It was fairly high speed, and it actually pulled a vacuum on the stern tube when it was getting up on a plane, and it sucked the water out of the stern tube faster than it would go in, and it caused this tide seal, which has a centering bearing to keep the seal centered on the shaft. It caused the bearing to seize on the shaft, twisted the whole seal off its silicone hose, and the vessel was taken on water. And it was a very dramatic situation. So they were able to control it, and thank God they were able to, prevent the boat from sinking. But condition monitoring wise, I would say, monitoring your water flow and monitoring your temperatures may have caught this. But this, kind of goes to design issues as well. But, these are things that we don't want to have happen. We're here to prevent those. This is a bearing. This is a shaft seal that lost water, and it cooked so there's a silicon carbide face, there's a face type seal, and the seal without water gets hot, friction, and it cooked the rubber bellows that carries the silicon carbide face. And this can happen, any seal, no matter how well it's designed, needs to have cooling. So if it doesn't have lubrication and cooling and flushing water, it will overheat, and this is the outcome. And you don't want to have that when you're off Antigua. All right, so there's a what, again, it's a burned seal, no water. All right, and I touched on the engine mounts. Somebody said to me, Rich, everybody thinks all you do is talk about engine mounts. Well, engine mounts are important. They take the thrust of the propeller and they take the torque of the engine, and they're actually a precision design component. They do what's called a 6 degree of freedom calculation to calculate the natural frequencies, yaw, pitch, and roll, vertical, horizontal, and axial vibrations, to make sure that when you're running at a specific speed, this thing isn't shaking itself off the foundations, like that Tacoma bridge that failed. Everybody saw that one, right? So this is the same thing. So what happens is, when these mounts are not installed properly, and you can see that one's slightly cocked, what happens is the rubber internally is pinched, and it changes the stiffness characteristics, and it changes the vibration characteristics. There's another one. Seems like a minor thing, like the rubber mounts, it shouldn't matter. It matters, because it'll create vibration. It'll cause misalignment as well, because when the thing goes into torque, it's going to want to settle on that mount, and if it's cocked, it's going to throw it out of alignment. Okay, this is a torsional coupling which was out of alignment, and it absorbed the alignment for a while. So what it does is it takes the energy from misalignment and it converts it to heat. So that heat gets absorbed for so long, and then eventually the thing fails. And that's what happened here. So, and it was 6 millimeters low because the mounts were settled over time. Rubber mounts will settle, and if it's not aligned properly, that's what happens. Okay, and I talked about pre and post vibration surveys. And anybody have any questions? Yes.
So say you take a brand new boat, get it in the water, and you guys dial it in, do your alignment check. Is there a time frame that you would recommend, hey, let's do this again? Because eventually it's going to go, things are going to vibrate themselves, it could be 3 years, 2 years, whatever. Would you recommend, say, 3 years, let's do it again kind of thing? If you don't have any visible problems, say, like something that, okay, or a bearing went out and cutlass bearing goes out, and now we're out of a line, now we got to do it again kind of thing. Is there any kind of recommended time frame that you would do it again?
That's a good question, because, and it's actually not a completely simple answer, but I'll give you the short version. So when these vessels are first built, the engine mounts, the properties of rubber, the mechanical properties of rubber, and if it's sitting on rubber mounts, which most vessels are now, because everybody wants quiet boats. So the first year on a rubber mount, the mount creeps, what's called creep. 90% of the creep is in the first year of service. So creep is going to cause the engine to settle down and potentially throw it out of alignment. So in the first year, I would recommend you do an alignment after 1 year of service. So after the initial build, 1 year later. After that, the creep is diminished, and really you shouldn't, I look at vessels, major maintenance is 5 years. Most major maintenance cycles is 5 years. So I would say that in the next 5 year cycle, you do your normal maintenance. Then you do another alignment. Hopefully without any incidences or touching bottom or anything like that, which never happens. But, those are the things that, would cause you to have to do a realignment. Just like when you hit a pothole with your car, you'd have to do an alignment. So The answer is I would do an alignment after 1 year, and then following that first year, you could go every 5 years.
We got another question back here. Rick?
Hey, good morning.
Morning.
You talked about galvanic corrosion. Do you recommend any type of potential testing for, electrical potential around a boat or anything like that? You recommend it on some kind of consistent basis, or how do you guys look at that?
I'm not an expert in that field. I know people that are, and I'd be happy to share their names with you. But I've seen the end result. We just did $250,000 worth of hydraulic work on a yacht that had a oil cooler fail from galvanic corrosion. Stray electrical current in a marina can cause a nightmare, and I would absolutely, yes, recommend that there would be a survey done.
Back there, Paul.
When you do an initial vibration analysis and you develop a baseline of, say for instance, a very efficient boat, you know from that analysis that the boat is running well, is there a system or a detection system that's simple that would detect when it goes out of that baseline or out of a certain parameter? You wouldn't necessarily know exactly what was wrong, but you'd know something is wrong so that you could easily say, okay, we need to get the boat in for an analysis.
Unfortunately, I'm biased. We represent a company out of Germany that makes a vibration monitoring system called VibeGuard. It's basically $1,000 per vibration channel. So we have a 6-channel system that it's the light version of it, and there's a Sportfish up in Palm Beach that has that system. They have a 20-channel system, so they use it and they love it. The owner is able to see what's going on in his boat from New Jersey, and he monitors this thing. It's like a video game for him. I don't know of any alternatives that are much cheaper. It's usually about $1,000 per channel. That's kind of the industry standard. There may be cheaper systems. They don't offer as many they don't offer as many features. Like you can't really dig and you get like, well, for example, in vibration we have overall vibration, and then we have frequency data, spectrum data. The frequency data allows you to see discrete frequencies, so you get a plot of frequency versus amplitude. Overall data is just taken, hey, between 10 to 100 hertz, we're measuring the overall vibration. That's kind of risky with boats because you could be in heavy seas and get high vibration, right? Whereas you're doing frequency analysis, you can pinpoint it to specific components. I hope I answered your question.
I have a sense that there's a guy from Nautic Alert who might be able to talk to you a little bit about that too.
I'm sure.
I have a question for you, Rich. Having been a broker for a long, long time, one of the things that we're all sensitive to is costs, as Bob had mentioned a little while ago when he was talking about the Nautic Alert system.
Yeah.
What kind of costs are we involved in? Are we involving ourselves in? When someone calls AME Solutions to come out and do a baseline analysis like Kevin was mentioning, are we talking about $1,000, $5,000, $25,000? And in the grand scheme of things, where does that relate?
We have a fixed price for doing a vibration survey, and it's, just to put it in, what we do is we figure a vibration survey, we allocate 4 hours on the boat for doing that. And then we allocate 8 hours in the office to analyze the data and write a report. So you're looking at a 12-hour charge. Do the math.
Okay. All right. And then in the grand scheme of things, when you look at the cost of that and develop a baseline, and you're able to save money on doing cutlass bearings or other maintenance items, that's not a very expensive consideration.
No.
Thanks.
And I have an example which has kind of baffled me at the time. This guy had a 35-foot lobster boat up in Solomon's Island, Maryland, and he had been chasing this vibration problem for over a year, and it was driving him nuts, and he was spending thousands of dollars. They modified the hull form, they changed the propeller. They changed I mean, they were like just throwing money at this, and he wasn't getting anywhere. It wasn't fixing it. So he gave us a call, and I got a trip to Solomon's Island. The guy owned the Holiday Inn up there. And we did a vibration survey and found the problem was a structural resonance problem. And the simple solution for him was to change from a 4-bladed to a 5-bladed prop, and he couldn't have been happier. And it was, I mean, for a lobster boat, I'm like, you're gonna fly me up there? You sure about this guy?
We have time for one more question.
As an example of commissioning a new boat, let's say with a 1,000 horsepower engine, on initial setup and commissioning, if we brought you people in to set up a baseline measuring, say, vertical clearance of the motor mount, the metal parts,
Okay.
before the rubber compressed, if you set up a baseline for that and spent maybe 3 or 4 hours on the boat, and then the owner went away, cruised his boat for a year or two, what would be a reasonable amount of compression that, say, an owner or a captain or an engineer on a boat could say, this is compressed to a point where we better do something about this?
Again, there's,
That's not
there's
easy.
kind of a simple answer to so it depends on what's called the shaft stiffness matrix, right? So,
oh, of course, I knew you were going to bring that
Yeah,
into the discussion.
yeah.
Yes.
So
Good.
if you have a bearing, say you have a forward stern tube bearing and it's 3 feet away from your close coupled engine and gear, then you're going to have a very stiff shaft system. And it's not going to be very tolerant of misalignment. And that would require, so if the mounts settle, it means that you're going to be loading your forward bearing more. If you have a shaft system where you have an aft stern tube bearing and you have 6, 7 feet, the angles are going to be less, and your alignment, you could settle down 1 millimeter on the mounts, it would have no effect whatsoever. So the answer is it really depends on the arrangement of the machinery. Some systems are more sensitive than others. And that goes back to the naval architect. And like Dan was saying, some naval architects are better at certain things than others. A lot of the guys, I've seen some driveline arrangements that I scratch my head and like, boy, you're making this so complicated. Why are you making this so complicated? Keep it simple, right? So, it depends on, what the boat's used for. So I would say, that's why you always want to try to have, you don't want to make the shaft too big because it'll become too stiff. And you don't want the bearing spacings too close because it'll make the shaft system too stiff. You want this thing to have as much flexibility as you can reasonably allow. And that needs to be given a little thought. If you make it too generous to spacing, then what you'll have is the shaft will act like a jump rope. And that'll create a lot of vibration. And we've seen that. So we've had to actually remove bearings from systems, and we've had to add bearings from systems, depending on the arrangement.
And one quick thing, what's your opinion of the oil bath torque tube type systems that are used on a lot of boats now, up to maybe 5,000 or 6,000 horsepower? Are you seeing that as the way to go in the future, perhaps?
I like the keep it simple, whatever principle. Those systems, the benefits of them are corrosion problems are alleviated by having the shaft sitting in an oil bath. They're a lot more efficient propulsion-wise. You don't have as much dirty. When your shaft spins in open water, it creates a vortex, and that goes into the prop, so that you lose efficiency. So there is benefits to those systems. The downside is they're very vulnerable. If you get a fishing line wrapped around your prop and you lose the shaft seal on those things, you've got water intrusion. Downside of them. They have pretty robust shaft seals. They do account for that, but we've seen that happen. They also, they're very stiff, so they need to have, when you align to those, they need to be properly aligned. So, you know, that's my take on it. I think there's benefits, pros and cons to both.
Thanks, Ray. That's great.